Welcome to Grip 9's presentation. Our discussion will focus on the robot's input and output systems, its cleaning mechanisms, and demonstration of model operation. We've added bump sensors at the back of the left and right sides to let our robot know if it's hit an obstacle. And for the cliff sensors, we've placed infrared ones at left, right, front left, and front right corners. These help our robot avoid taking a tumble off a ledge by sensing if it's too close to the edge. They return us a simple yes or no answer. For the wall sensor, we have used infrared technology to measure the distance to nearby objects in centimeters, ranging from 1 to 10 centimeters. This sensor helps our robot to detect obstacles close up and adjust its path to prevent collisions, especially when moving forward by utilizing the sensor's distant readings. For the output, the robot's left and right wheels are its main drivers of motion. In forward mode, they spin the same way to move the robot ahead. When in reverse, they spin oppositely to back it up. In the cleaning part, our robot goes through 6 movement states: forward, reverse, rotate right, step forward, rotate left, and idle. In forward, it moves ahead with both wheels. When bump sensors detect an obstacle, it will prevent collisions by reversing. So if they hit something when reversing, the robot will step forward and then change direction. For the rotation part, it uses rotate right or left, with one wheel moving and the other stationary for a smooth pivot. The step forward state allows for small adjustment, crucial in tight spaces. Additionally, the idle state acts as a safety mechanism, preventing the robot from making potentially harmful movement when the next action is unclear. This comprehensive system ensures efficient navigation and effective obstacle avoidance. Now we will demonstrate our robot running in different situations. Firstly, by clicking Run button, the robot can easily move forward and backward, controlling both wheels at the same time or reversing when needed. For the wall sensors, now we set the value of 5 centimeters for the distance of an object. We could see the robot navigating before it comes to 5 in the graph. It maintains a safe distance from obstacles, adjusting its path when necessary. Secondly, we will test the left and right bump sensor by entering 5 and 50 into the wall sensor respectively. If the wall sensor reads 50 centimeters, it means there's plenty of space before the robot reaches an obstacle. Thus, the robot can take its time to decide the best way to navigate, whether it's turning left or right, without the immediate risk of hitting anything. After changing the input from 50 to 5, it means the robot detects that it's nearly bumping into something through a bump sensor and changes direction quickly, and continues to move forward to avoid a collision. Finally, we input 5 and 50 centimeters into the wall sensor to test the cliff sensors. At 5 centimeters, the right cliff sensor signals the robot it's near a cliff and should avoid moving right. Conversely, if the sensor reads in 50, the robot can adjust its path away from the cliff if the right cliff sensor is triggered due to more space on the right. The robot can safely adjust its path if the right cliff sensor triggers. Similar to the right cliff sensor, the left, and front right cliff sensors are tested with 5 and 50 centimeter wall sensor readings to ensure they prompt the robot to avoid cliffs when close and allow for safe path adjustments when further. Furthermore, in the following testing cases, it can turn left and right to change direction by rotating one wheel while keeping the other still. In conclusion, our robot has demonstrated to move forward, backward, left and right, avoid obstacles in all directions, also effectively prevent falls with cliff sensors.